Hello students, I am Manish Gupta and we are learning here kinematics. This is the fourth lesson of kinematics, and in this lesson we are going to discuss graphs of displacement, velocity and acceleration. Look, we are taking a situation where a particle is at t equals 0 moving with velocity vi and accelerating uniformly with acceleration a. At t equals t, its velocity is v, so we can write this v as vi plus at. What will be displacement at t equals t? We can write this displacement vi t plus half a t square. So this is the situation where this particle is accelerating with acceleration a, right? So now, if you are interested in drawing the graph, that is variation of velocity with time, that will be v equals v at any time t equals initial velocity plus a into t. So you will see it's a linear variation. So our graph will be a straight line between velocity and time. Let's initial velocity is this vi, then its graph will be like this. Here students, you will see slope of this graph is a, and that's the acceleration. That means slope of velocity time graph will give us acceleration. Second way we can consider delta x, displacement variation. So delta x we have vi t plus half a t square. Look at the situation, it's a quadratic equation, right? Here delta x is vary with t as a quadratic equation. That means graph will be parabola, right? Graph will be parabola. So students, if you are going to say on y-axis delta x and on x-axis time, so we are drawing the variation of displacement with time. So it will be a upward parabola, right? You will see it will be a t square has the positive coefficient, so it will be a upward parabola. At t equals 0 we can say displacement is 0, so graph will go like this. Students, if you look rate of change, slope of this graph will give us speed. Slope of this graph will give us speed, right? Because if you are going to write slope, it will give us speed. Slope of this graph will give us speed. So you see here, you will see here speed is continuously increasing, so that the slope is also increasing here, right? We can take the another situation when at t equals 0 particle has some velocity vi, but instead of getting accelerated it's getting retarded. It has uniform retardation of minus a, and at t equals t, if you want to write its velocity, that will be vi minus at. So in this situation, what will be the graph? Variation of velocity with time. In this situation, initial velocity we have some vi, and from some vi it will be decreasing, right? Vi minus at. Here slope you will see will be minus a, right? And also if you want to write delta x, so student delta x will be VIT minus half a t square. So it will be a downward parabola. So if you are going to draw a graph between displacement and time, and time, it will be a downward parabola. Initially downward parabola like this, right? Initially it is, we can consider at t equals 0 its displacement is 0, right? It's moving with some velocity, and with time its velocity is decreasing, its speed is decreasing. Look at the slope will give us here speed. So now we are going to take some examples. For example, first we are going to take a llama goes gracefully in the positive direction at a constant speed of 3 meters per second for 3 seconds. So for this situation, if you are going to draw the graph between velocity and time, then velocity is constant for time interval, right? And if you are going to draw the delta x displacement versus time, and if you are going to draw the graph between acceleration versus time, so the students, acceleration is 0. So when acceleration is 0, can we write delta x will be v into t, right? So it will be a straight line graph. Here slope will give us velocity, right? Now velocity versus time graph. Variation of velocity with time is constant. So it is 3 meters per second moving for 3 seconds. Time is in second. Acceleration is 0. So this is 0 till 3 seconds, right? Let's take this situation. An alpaca is initially at rest. The alpaca is started by a fierce capybara and starts running at t equals 0 at a constant acceleration of 1 meter per second square for 3 seconds. So students, can we write velocity vi plus at any time t, velocity vi plus a into t. So v will be 0 plus 1 into t. So v equals t. So if you are going to draw the variation of velocity with time, that will be directly proportional, that will be that. So the graph here will be a straight line, right? At t equals 3 seconds, velocity will also be 3 meters per second. If you are going for position time graph, so delta x we can write displacement time graph, right? So delta x we can write VIT plus half a t square, right? So delta x we have initially at rest, so Vi is 0, half t square. So it's a upward parabola, right? So variation of delta x will be, variation of delta x with t will be like this. At t equals 3 seconds, we can put here 3 seconds, then delta x will be, put 3 here, 9 over 2, 4.5 meters. This is in meters. Next, we can also draw the graph for acceleration time. acceleration is constant 1 meter per second square for 3 seconds, right? Take say another situation. Initially at x equals 1, at t equals 2 second, the capybara moves in the positive direction at x equals 2 at a constant velocity and stops at t equals 3 second. Then it stays there at rest. Let's draw the graph for this situation. Initial situation is x equals 1. Let's draw the graph of variation of velocity with time. So at t equals 2 second, the capybara moves in the positive direction to x equals 2 meter at a constant velocity and stops. So for 2 seconds it is at the same position, right? And then moving with constant velocity for 3 seconds, till 3 seconds. So for 1 second it's moving with some constant velocity. Now if you are interested in drawing the graph of acceleration throughout the motion acceleration will be 0, right? Throughout the time interval acceleration will be 0 to 3 seconds acceleration will be 0. If we are interested in drawing the graph variation of position with time, so initially it was at